everyone. So, this is the next part of the linear motion topic. For the most part, I said before that a lot of the toughness and difficulty in this first topic comes from students still trying to get their bearings as far as doing the reading comprehension skills and pulling out the equations and doing all the math. This is the other part that students do somewhat tend to have problems with, but this kind of goes back to algebra, and in particular, anyone who's taking calculus will end up understanding this. But what we're going to end up talking about in this one is how we can graph motion, distance, velocities, and accelerations as function of times in order to basically get an idea of what the object is doing. So, common thing of like, what is the purpose of a graph? Their graphs serve multiple purposes. So one thing is it helps make data look much more organized and neater. For example, back when I was doing lab work over at Stony Brook, I remember there was this one lab that we did where we had to collect data on the the energy being released by radioactive materials in order to determine their half life. And we ended up getting a ton of data, probably close to 1,000 points of data. When you looked at the data, it made no sense. But once we graphed it, we did end up seeing that nice decay curve that we should get from something that's radioactive. It could also condense data into a small area. Going back to that same idea, the 1,000 data points that we had was pages and pages worth of data, and then we were able to simplify it all into a nice little tiny graph. Um, Graphs can also show trends. So is something going up, going down? How is it going up? Is it starting to reach a plateau? Something like that. And the last one is that it can tell a story, and that's kind of what we're going to be sort of focusing in this class is being able to look at a graph that is either a distance graph, a velocity graph, or an acceleration graph, and be able to come up with an explanation of, well, what is the object doing based on that graph? Um, so this is a graph, just kind of getting that around that whole like telling a story thing. Um, this is a graph of my daily mileage driven in my car. So when I was younger, actually I still do it, but one of the things that I tend to do is anytime I fill up on my car, I just write down what my mileage is, and then when I get home eventually, I'll put it into a spreadsheet, and it automatically calculates how much I roughly drive per day based off of my fill ups and all that stuff. So this is going from 2008 to about 2000, yeah, late 2014. Now, there are these weird peaks here. So these are when I went to work in college. Um, yeah, you can tell that I started driving a lot more in these areas, and then when I wasn't at college, it dropped back down. So you can see that kind of trend. This one's the more interesting one. This was when I dated a girl who actually didn't drive, and you can actually see that this entire part actually gets repeated, but it's just shifted up a few. And when I looked at the data, it turns out that the amount it gets shifted up by is the exact amount of round trip driving to get to her house. This is when I went on a long distance trip to Jersey, longest that I've driven. And then this is when I started commuting a lot between my house, Stony Brook, and Southampton. So you can kind of get an idea of what was going on based off of these peaks and stuff. You could tell that there are certain areas and times when I start driving a lot, and when you compare it to the times, you can see kind of like what I was doing. Like if it was summer, you'll notice that there wasn't that much driving, but then during the spring and fall, there was a ton of driving. Of course, we're not going to be doing something like this, but I just thought it was an interesting thing to show. So going back to what you have to do as far as like what does it mean to tell a story. So this is our first graph that we're going to look at. Now we're going to start with displacement graphs. Now remember, displacement is your position. So that's actually why it says position on this y-axis. So it says here that when we start the graph, We start at a position 2 meters away from some place. After 60 seconds, I'm still 2 meters away, and after 120 seconds, still 2 meters away. What's the car doing? Well, first thing that we could tell is that this graph has a zero slope. It is not going up, it's not going down, it has no slope at all. We can also tell that the object isn't moving because this number isn't changing at all. It's staying at 2 the whole time. If an object starts 2 meters away from you and continually stays 2 meters away, clearly it's not moving. Another thing that we could say is that it's at rest. So from this graph that has a zero slope, we can tell that the object is not moving and it's remaining at rest. All right, now we're going to go into the next displacement graph. So here, this is for a plane. We could do the same thing. First, let's try and think about, well, what does the graph look like? If you had to describe the graph, what type of slope does it have? Well, since it's going up, we could say it has a constant slope. Now, I want to go back and compare this to the previous graph. The previous graph had what we call a zero slope, but the graph was constant because the number didn't change. Don't get that confused with me saying that this is a constant slope. So this graph is changing. It's just changing at a constant rate. So try to make sure that you differentiate a graph that is constant, like in the previous graph, and a graph that has a constant slope. All right, so going back to here, so this graph has a constant slope, so we can go back to our original question of, well, what is the plane doing? Well, it's starting at 0, and then after about 50 seconds, it's 50 meters away. After 100 seconds, it's now 100 meters away. So we can actually see that it's going away. So it is moving away, and we also can tell that it's moving at a constant speed. Within 50 seconds, it moves 50 meters, and in the next 50 seconds, it moves another 50 meters. So this plane is moving away, and it's doing it at a constant speed. So this slope, that's constant slope, constant speed, moving away. Now, a good question would be, how can we determine how fast it goes? So is there a way to look at this graph to determine how fast this plane is going? Well, the main equation that we have for speed is v bar equals d over t. So we can figure out, well, how much distance does it cover and how much time it covers. Wait a minute. Distance is on the y-axis. So we'd be basically figuring out how much the y increases. So let's say it's the change in the y. And time's on the x-axis. And once again, we'd figure out how much the time changed by. So this would just be change in time. Change in x. Ooh, interesting. Change in y over change in x, that is the slope. So it turns out that the slope that we have will dictate what the speed of the object is. All right, going back to here. So now it's same plane. We can figure out what is the plane doing. Well, let's go back to what we did before. What's going on with the slope? Well, the slope is still constant, but this time it's going to be a negative slope. So it's going to be a constant negative slope. We also know that it's moving back because, again, it starts at 100 meters away, but then it goes down to 50, then it goes down to 0. And once again, because the slope is constant, we can tell that this is a constant speed. Within 50 seconds, it moves back 50 meters. The next 50 seconds is another 50 meters. So far, we've started to realize that there is this relationship when we're looking at these displacement graphs between the slope and what's going on with the speed. Now let's look at this one. First off, how would you describe what's going on with the slope? And then can you come up with a story with what the player is doing? Well, if we look here, the graph starts off flat almost. It starts off like this. So this starts with a zero slope. But then as we continue, we could see, oh, that was bad. We could see that the line starts to get steeper and steeper and steeper. So this has an increasing slope. It starts at zero, it starts flat, and then it starts getting steeper and steeper. So it's got an increasing slope that's positive. We could tell it's moving away since the displacement is increasing, and we could tell that it's going to be increasing in speed because again, the slope's increasing. It starts off not really moving that far, and then all of a sudden it's moving further and further and further away in the same amount of time. So it has to be moving with an increasing speed. All right. So the big takeaway for all of this is the fact that if we take a displacement graph and we take the slope of it, we get the velocity. And we can see that by looking at the graphs we had. This was zero slope, zero velocity. This had a constant slope, this had a constant velocity. This had an increasing slope, increasing velocity. And of course, the sign on the slope will also dictate the sign of our velocity. A positive slope gives me a positive velocity. All right? So that's the main thing with this, is that if we take the slope of displacement, we get velocity. All right, so here is the question on displacement graphs. So you can pause the video, work itself, and we'll go over in a second. All right, so here what we end up having is a graph right over here. There's four sections. There's A to B, B to C, C to D, and D to E. We look at this first part, wants to know which part is motionless. So if we look back, we had a graph that looked like this for displacement. We had this graph, and then we had this one. This was the object that wasn't moving, object moving with a constant speed, increasing speed. So for the motionless one, I'm looking for something that looks like this. So the only section that looks like that is C to D. So C to D is motionless. All right. Now the next part, moving with constant speed. Well, again, this was motionless. This had a constant slope, so it's a constant speed. So that means I have actually two areas that look like this, B to C and D to E. Now, one thing I would note is that with some of these questions, you want to note if it says anything else besides just constant speed. Sometimes it will say moving with a constant positive speed or a constant speed towards something, and that would usually be meant to kind of specify whether it's B to C or D to E, because B to C is going to be moving away and D to E is moving towards. Okay. And the last part, the one of acceleration. So this is my acceleration graph, because this is the one that has the increasing speed. The only part that looks like that is A to B. And that's it for this part. Alright, I'm gonna leave the video here. I'm gonna end it at this part, and you'll end up doing some more practice questions dealing with displacement graphs in a bit. It's extremely important that you're able to look at a displacement graph and determine pretty much what the velocity is and what the object is doing based off of how it's shaped. Alright? If you have any questions, let me know. Otherwise, I'll see you later. Bye.